All right, we're going to be taking the derivative of a quadratic function using the limit definition of derivative. All right, so what we want to do is calculate f prime of x. I've gone ahead and posted the limit definition of derivative over on the right-hand side. So we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So initially what we want to do is we're going to plug in x plus h in for each of the x's in the original function. And that's going to go up in the numerator. So we'll bring along limit as h approaches 0. And then as we replace in, we'll have 5 times x plus h, quantity squared, plus 8 times x plus h, plus 3. Next, what we want to do is subtract away, and I'm going to use a big set of parentheses to indicate this, f of x. So inside that big set of parentheses, I'm going to replace it with the original function, the right-hand side of that. So we can say 5x squared plus 8x plus 3, and that's all over h. Next, we can't directly substitute in 0 for h. All right, taking this limit, eventually we want to put a 0 in where our h is, but we run into a problem if we try to do it initially. We would get a 0 in the denominator, and dividing by 0 is not okay. So instead, what we want to do is take our time, do a lot of algebra, and simplify down the numerator, eventually in the hopes of getting rid of this h from the denominator. So think about this as x plus h times another copy of x plus h plus 8x plus 8h. I'm going ahead and I'm distributing this 8, clearing out our parentheses and multiplying 8 by each one of those terms inside the parentheses. Next, we have a plus 3 coming along. And again, I'm going to visualize this as a -1 that needs to be distributed to each one of these terms inside of this set of parentheses to get rid of it. So minus 5x squared minus 8x minus 3. From here, we can still multiply out. You can see that we have 5. And then if I take my time and do first outer inner last, or distributive property, FOIL, we're going to get x squared plus xh plus xh plus h squared inside that set of parentheses. Now at this point, we may go ahead and say, well, we have 8x minus 8x. Those get to cancel each other out. We have a positive 3 and a minus 3. All right, that becomes 0 as well. So you can kind of get rid of those as we go through and simplify as we go. We haven't gotten rid of the plus 8h, the minus 5x squared, or the h from the denominator. And really, it's all a lot of algebra. So really just take your time as you go through this. I'm going to go ahead and distribute the 5 to clear out this first set of parentheses. You could have combined our like terms first. We have xh plus another xh, but I'm going to go ahead and distribute first. So 5x squared plus 5xh plus 5xh plus 5h squared plus 8h minus 5x squared coming along. Again, we do have some more like terms at this point, so let's go ahead and combine our like terms. That limit as h approaches 0 just kind of comes along from step by step until we can get rid of the h from the denominator. At this point, we do have 5x squareds minus 5x squareds, which creates 0x squareds. And we do have 5x's plus 5 more x's, which makes 10xh's, I should have said. All right, combining these two terms together. All right, we also have 5h squareds plus 8h's in our numerator coming along over an h in the denominator. From here, we have a common factor for all of our terms in the numerator, which is sort of what we're looking for. They all have h in common. So if we factor out that h, the common factor, we can say, well, we have 10x plus 5h plus 8 inside the set of parentheses and still an h in the denominator. But at this point, once we have a factored h in the numerator and an h in the denominator, these create a 1. Like h over h becomes 1. So we have the limit as h approaches 0 of 10x plus 5h plus 8. And at this point, because we've gotten rid of the h in the denominator, we can do a direct substitution and put 0 in for our h. So if we put 0 in for our h, we have 10x plus 5 times 0 plus 8. Obviously, multiplying by 0 makes 0. So 10x plus 0 plus 8 makes 10x plus 8, which will be the derivative of our original function, f of x. Now, if we wanted to, if we were asked to find the instantaneous rate of change at a specific value for x, or the slope of the tangent line at a specific value for x, like let's say we had x equals 2, calculate the derivative there, what we're going to do is we're going to plug a 2 into this derivative function that we found. Say 10 times 2 plus 8 would be 20 plus 8, which would be 28. And I just used 2 as a specific number. Could be used for any other value given to you for x. All right. Hope this helps. We'll see you next time.